You are welcome back to the continuation of our lecture on homologous series. Like I stated in the last video, I stated that an homologous series is a family of organic compounds with a regular and repeated structural pattern in which successive members differ from each other by CH2 or a molecular mass of 14 subunits. And like we already discussed, the characteristic of homologs, which we described as members of an homologous series. So there are several homologous series. We have the alkane homologous series, we have the alkene homologous series, we have the alkyne homologous series, we have the alkanol homologous series, we have the alkoxy-alkane homologous series, the alkanamine homologous series, the carboxylic homologous series, and a host of others. But one thing about most of these homologous series is that they have the same functional group. So today we are going to be starting with the alkane homologous series. The alkanes are a special class of compounds. We call them paraffins. And the reason we call them paraffins is from the word paraaffinine. The word paraffin comes from the word paraaffinine. When we look at these two combinations, the word affinine means love. The word para means paraffin in this concept is describing less affinity, lower affinity. So technically, the alkanes are described as a class of compounds that do not react. They are less reactive. And the reason why they are not reactive is because of their saturated nature. So the saturated nature of the alkanes reduces their reactions. So, however, today we shall be discussing this class of compounds. So, alkanes can better be described as a family of organic compounds that have a general formula of CnH2n plus 2. So, this is the general formula, GF. GF here is the general formula. So the general formula of your alkane is CnH2n plus 2. Please take note of the way it is written. Most candidates in external examination would write it this way. Writing it this way is wrong. You must take note of those numbers written as subscripts. For examining bodies like IJMB and JPEG, you will not be scored if you wrongly write your general formula. So please ensure that you write it in such a way as to indicate the subscript in the proper manner. So alkanes are organic compounds with carbon-carbon single bond. They consist of carbon-carbon single bond and they are aliphatic. In my previous lecture on Introduction to Organic Compounds, in the chart that I made, I illustrated that alkanes can be described as, we have alkanes described as being acyclic, then being aliphatic, hydrocarbon, organic compound. So we can say alkanes are acyclic. Okay, we still have something here. They are saturated. So alkanes are saturated, acyclic, aliphatic, hydrocarbon, organic compound. They are said to be saturated because they are single bonds. They are said to be acyclic because they are not closed. Their chain is not closed. They are said to be aliphatic because they are made up of chains. They are said to be hydrocarbon because they are made up of primarily hydrogen and carbon, and they are organic compound because they are carbon-based compounds. So getting back to where we stop. So today we shall be explaining to you how you can give the structure of an alkane once you know the number of carbon atoms. So here, if the number of carbon atom is 1, let's take note of the formula. The formula says we have CnH2n plus 2. That means that anywhere we see our N, we are going to be inserting this number. Anywhere we see our N, we are going to be inserting this number. So if my N is 1, so let's substitute. I mean, anywhere I see N, I'm going to put 1. So bringing that here, what do I have? C. N is what? 1. plus H, I have H, 2, anywhere I see N, I put what? 1, plus 2. C1, that's, since it is 1, I just write it as C, H, 2 times 1, that's 2, plus 2, 4. And this gives me my methane. Similarly, if my N is 2, what do I have? Anywhere I see N, I put my 2. So I have C, N, that's 2, H, 2 into bracket 2, plus 2. C2, 2 times 2, that's 4, that's H, 4, plus 2, that's 6. So that gives me C2, H6. So that is what we are going to be applying in this table. So let's go ahead. The molecular formula for this, remember Cn, H2n plus 2, C1, H2 times 1, 2 plus 2, CH4. That is my molecular formula for. And the name of this compound, when it is 1 carbon, we say it is met. When it is 2 carbon, het. 3 carbon, prop. 4 carbon, but. 5 carbon, pent. 1 carbon, met. 2 carbon, het. 3 carbon, prop. 4 carbon, but. 5 carbon, pent. 6 carbon, x. 7 carbon, x. 8 carbon, oct. 9 carbon, 10. 9 carbon, none, while the 10 carbon is there. So we're coming back, name of compound here is met, because 1 carbon is met, and it is alkane, so we have methane. What would be the expanded formula? The first thing we must do when we are trying to draw structure is that our carbons usually have a carbon-carbon structure. And the number of bonds around our carbon atom should not be less than 4, and neither should it be more than 4. So carbon is usually tetravalent. So let's come in. So expanded, I have carbon. How many carbon? 1. Number of bonds around my carbon should not be more than 4, no less than 4. I have 4 hydrogen there, so I should have 1, 2, 3, and 4. And this is our methane. For the condensed structure for methane, we just leave it. Stick formula is just a single dot, but we can look at other ones. When my N is 2, that means C2, H2 times 2, 4 plus 2, 6. So therefore, you have now understood that the formula for your methane, for your carbon 2 will be what? C. N, anywhere you see N, you put 2. H, 2 times 2, 4 plus 2, 6. C2, H6. What will be the name of the compound? 2 carbon is, remember, 1 carbon is met, 2 carbon is het, 3 carbon is pro. So now we are talking about 2 carbon. You got that right. So that should be C. Then, what will be the expanded formula? We have 2 carbons. So the first thing to do is to bring the 2 carbons together. So we have 1, 2 carbon. Then the number of bonds around your carbon should not be more than 4, nor less than 4. So this carbon atom already has 1 bond here. So the remaining hydrogen, to make it 4, 1 minus 4 is 3. So we have 3 more hydrogens left. 1, 2, and 3. What about this? This carbon has 1 bond. So it's remaining how many bonds left? 3. So we have 1, 2, and 3. This compound is referred to as ethane. And now, going to the condensed formula. To explain the condensed formula, we need to know the number of carbon. How many carbon? The first carbon here has 1. This is the first carbon, that is 1 carbon. Has how many hydrogens surrounding it? It has 3 hydrogens surrounding it. Then the second carbon has how many hydrogens surrounding it? 3. How many hydrogen attached to it? 3. CH3. Then the stick formula. So this is the condensed formula. The stick formula for this will go this way. We are assuming in this explanation that each of these edges represents a carbon. So this is 1 carbon, this is what? 2 carbon. So this is how we describe. So if it is 3 carbon, it comes like this. If it is 4 carbon, it goes like this. If it is 5 carbon, it comes like this. If it is 6 carbon, it goes like this. So, since we have only 2 carbon, it reflects this way. Then, for 3 carbons, molecular formula is going to be, anywhere you see N, you put 3. So this is what? C3, H, 2 times 3. That is 6 plus 2, that's 8. So therefore, what do I have here? H8. What will be the name of the compound? The name of the compound for 3 carbon, remember, it is pro. That gives me propane. That gives me propane. Then, what will be the expanded formula? The expanded formula, of course, remember, this is 3 carbons. So I'm going to be having, early, by this. So we are going to have expanded 1, 2, and 3. Number of bonds surrounding each of your carbon atoms should not be more than 4, nor less than 4. So this carbon has how many bonds? 1. Remaining how many? 3. So you have 1, 2, 3, and 4. This has how many bonds? 1, 2. Remaining how many? Remember, carbon should be having 4. So I have 1 and 2. This has how many? 1. Remaining how many? 1, 2, and 3. And writing the condensed, take note of each of the carbon atom and the number of hydrogens surrounding each of the carbon atoms. So the first carbon here has how many hydrogen? 3. CH3. The second has how many? CH2. The third has 1 carbon and 3 hydrogen. That's what? CH3. So that gives us 3 hydro. It gives us 3 carbons. So propane, CH3, CH2, CH3, and of course the stick formula. 1, of course, for 1 carbon, 2 for the second carbon, and 3 for the third carbon. So finally, I'm going to be using the fourth carbon, which is butane, to illustrate this. And at the end of this, I'm going to be giving you an assessment for you to complete this table. You can complete it all by yourself up to 10 or 20 carbons. So for 4 carbons, I'm going to be having 4. Remember, in SAT, anywhere you see it, that will be what? C4H. 2 times 4, 8 plus 2, that's 10. The name of the compound here is going to be called butane, because 4 carbon is what? But. Then, the condensed, the expanded formula tells you there are 4 carbons. So I have 1, 2, 3, and 4. And each of the bonds should not be more than 4, nor less than 4. So I have 1, 2, 3, and 4. This is 1, 2, 3, and 4. This is 1, 2, 3, and 4. 1, 2, 3, and of course we have 4. So this compound is called butane. So I believe you can guess what the contents will be. The first carbon is what? C. Yes, 3 hydrogen. That is correct. The second, C, with 2 hydrogen. Excellent. Then the third is what? C, with how many hydrogen? 2. Brilliant. Then the last one is with how many hydrogen? C, with how many hydrogen? Excellent. That is beautiful. Appreciate yourself. Then the stick formula. We are going to be having 1 for the first carbon. Great. 2 for the second carbon. Yes. 3 for the third carbon. We have how many? 4. 4. So at the end of this, you should be able to write for all the first 10 members of the alkane homologous. So that's the assignment. Write from all this up to carbon number 20. See you on the other side. Thank you very much for listening, and do have an amazing day ahead. Cheers.